Okay, hello everybody. So today we're going to be talking about inequalities. So the Common Core algebra, and it's REI, which stands for the reasoning with equalities and inequalities. We're doing the inequalities, number 12. So the Common Core says graph solutions to a linear inequality, which is what we're doing, inequality in two variables, as a half plane. Okay, what does that mean? We're going to figure that out. 2, 15, 17. So graph solutions to a linear inequality in two variables as a half plane. Okay, let's figure out what that means, all right? Graph solutions to a linear inequality in two variables as a half plane. All right, so let's take a look at example 1. So first of all, in example 1 we have this symbol. It's a greater than or equal to. It's not equal at all. In fact, greater than or equal to means that it could be greater than the line. So to be greater than the line means it could be everything above the line. So I have greater than, so what we're going to do is have everything above the line, which is a whole lot of points above the line. But let's graph the line first. Let's just go back to graphing the line. We know our y-intercept is -1, so we start at -1 on the y-axis. Our slope is 2/3. We're going to go from our -1. We're going to go up 1, 2, over 1, 2, 3. Okay, let's keep going. Slope keeps going, so we're going to go up 1, 2, over 1, 2, 3. I can even go backwards. Down 2, over 1, 2, 3. So I get a line, right? So I'm going to have to graph that line. I can do that. Let me get my fancy ruler called my credit card, because that's all I have on me. So I'm going to draw my line. Okay, here's my line. Now, if I read the question carefully, I want to be greater than the line, which is above the line. So there's two half planes. Here's my half plane. You've got above the line and below the line. So we want to shade everything. We want to represent all of these points. So I mean, there's a whole lot of points above the plane. I mean, there's points everywhere. All of these points are solutions. Every one of these points are solutions to this example. For instance, if you take 0, 0, 0 would be greater than -1. Yeah, that's true. Any point up here, if you plugged it in, would work. Now, that's a whole lot of points. So what we do, and I'm sure you guys remember this from algebra, we shade. We shade the entire half plane. Because if we shade the entire half plane, we are going to represent every single point, including the decimal points in between. We shade the entire region. That's my half plane. So every point within the shaded region is a solution to this system. All right, let's take a look at number 2. Now the only difference in number 2 is that it's less than and there's no equal. So when I graph the line, I got to make sure that I don't graph the line. Well, how do I do that? I got to graph the line but don't graph the line. Well, let's start at 5. 1, 2, 3, 4, 5. I know the slope is -2 over 1, so I'm going to go down 1, 2 over 1, down 1, 2 over 1, down 1, 2 over 1, down 2 over 1, right? Now, how am I going to graph the line but not the line? So the trick is this. the line, it says y is less than but not equal. So when I graph this, I'm going to put in a dashed line, okay? Because I want to show that the line itself is not part of the solution. So I put a dashed line. The reason I put a dashed line is there's no equal sign here, so it does not equal line. So put a dashed line to show it does not equal line. Now, less than. If I want to be less than this line, I have to be everything below. So everything below this line is part of my solution. So I graph this half plane, and every value, every point within this half plane is a solution to y is less than -2x plus 5. It's a lot of points. That's why we shade it. All right, example 3. So in example 3, we just need to solve for y. Solve for y so that we can end up getting it by itself and graphing it. So if I have my, I'll write it down here, my 3x plus my 2y is greater than 12, I'm going to bring the 3x over. Okay, so to bring the 3x over, I just have to subtract it. So I'm going to go minus 3x, minus 3x, okay? Do that. I'll only get a 2y is greater than, well, you can't subtract 12 and 3x. Don't subtract 12 and 3x. They're different. So I'm just going to go 12 minus 3x. That's what it is. 12 minus 3x, because x term, and that's a whole number. You cannot subtract them. Okay, still, though, back up, don't have y by itself, so I'm going to divide by 2, divide by 2, divide by 2, right? So that cancels and have y is greater than a 6 minus a 3/2 x. All right, that I can graph. So I'm going to start with 6 on the y-axis for our y-intercept. So I go 1, 2, 3, 4, 5, 6. Okay, start my y-intercept at 6. And then my slope is negative 3 over 2. So start at 6. I'll go down 1, 2, 3, over 1, 2, down 1, 2, 3, over 1, 2. And I can actually go up 3, back 2, right? I can do that. Now again, there's no equal sign, so it does not equal the line. So when I make the line, I'm going to have to do a dashed line. So, all right, draw in my line, dashed line. Greater than is everything above the line, so it's this half plane here, right? Easy, right? Easy. All right, example 4. Let's make ourselves a little side note. A little side note over here. Okay, for example 4, a little side note. Okay, when we divide by a negative, and I think Austin told us what it is. Austin the other day said when you divide by a negative, we're going to turn the sign, meaning we're going to turn the inequality sign. So right now, this sign is less than or equal to. When I divide by negative 4, when I divide by negative 4, I'm going to turn it to greater than or equal to. Okay? So when I solve it, I'll eventually divide by a negative, and I'll have to turn the sign. So let's do it. Let's go down and let's have our 3x minus 4y less than or equal to 12. Let's bring the 3x over. So we're going to subtract 3x, subtract 3x. I'll have a negative 4y is less than or equal to 12 minus 3x. Again, don't subtract those. It's not 9x because that's not an x. That's a whole number minus the 3x. Okay, here we go. Let's pull Austin's trick out of the hat. So divide by negative 4, divide by negative 4, divide by negative 4, right? So the 4's canceled, and the negatives cancel. And we'll have y. Now, because we divided by a negative, I'm going to turn the sign to greater than or equal to. Okay, turn the sign because I divided by a negative. Okay, and then this becomes a negative 3 plus, because a negative divided by a negative, 3/4 x. Okay, now I'm ready to graph it. With the big key on this one, divided by a negative, turn the sign from less than to greater than. Okay, so let's start at negative 3 on my y-axis, down here at 3, and then my slope is up 3 over 4, so I'll go up 1, 2, 3, 1, 2, 3, 4. I can do it again if I want to. 1, 2, 3, 1, 2, 3, and 4. I've got the equal sign, so I'm going to make my line part of the answer because it can equal the line. So on a solid line, got an equal sign, so I make a solid line. And now it says greater than, so I'm going to shade everything above my line. So that's all of this region here. So that's that half plane, all right? You guys liking all the colors? Aren't the colors kind of cool? I figured you like all the colors. Okay. All right, ready to turn the page? So let's go over. All right, 2 more problems here. Okay, first of all, if it's a y without any x's, hopefully remember that this is a horizontal line. I'm going to go up to 4, 1, 2, 3, 4. I'm going to draw a horizontal line. Slope 0, okay? So, the thing though I've got to be careful is I've got to make sure that this is a dashed line because there's no equal sign. So I'm going to make my dashed line, okay? Dashed line. So this is y is less than, and to be less than 4, it's like 3, 2, 1, 0. All those are less than, so I shade this half plane. Alright, that's not bad. Alright. Example 6. Okay, let's play Jeopardy. Here's the answer. What's the question? So I do know that I'm going to start with this. Y equals mx plus b, because that's the equation of the line in slope-intercept form, right? I'm going to at least start with y equals mx plus b. The next thing I got to do is I'm going to make it less than, because I shaded everything below, so I'm going to go y is less than mx plus b. And again, we're going to find m, and we're going to find b in a second. Now this is not a very good copy, but I'm sure this is the x-axis here, right? So the copy machine kind of made it pretty dark, and it's pretty hard to read, but we can figure this out. So if this is the x-axis at 0, then my b has got to be 1, 2, 3. This value has to be 3. I'll show you again. We counted up from the x-axis. We went up 1, 2, 3. So my y-intercept is 3. So we're going to put 3 right here, okay? Now the slope, it's a little hard to tell in the slope, but it looks like from here to here we'd go up 1, 2, 3, 1, 2, 3, 4, 5, 6. So I'm really going to go down 3, down 1, 2, 3, and over 1, 2, 3, 4, 5, 6. We're going to go down 3 over 6, which is a slope of y is less than down 3 over 6x. Okay, you know, some math teachers might accept negative 3/6, but I think we can reduce that pretty easily to negative 1/2. So let's rewrite this. Y is less than negative 1/2 x plus 3. So it does look like down 1 over 2, down 1 over 2, down 1 over 2. There we go. That's it. So homework for today. Here we go. And if you need graph paper, I've got some graph paper in my bottom drawer of my desk, and if you ask the substitute nicely, I'm sure she can get you some. So here's our homework. Page 128, 2, 5, 6, 12, 13, 19, 61, 62, and 63. All right, let's get started. Get on it right away, and if you need questions, just ask. We have a real math teacher here today. Yay, aren't we lucky?